Good people, Sanbonan. Today, we are proving theorem number 1 from theorem number 11. So if you're watching this video and we are doing grade 11 and you're also doing grade 12, we are really in a good place. Make sure you watch it until the end. We'll be proving this one, and I hope you still remember grade 10 works where the word congruency is gonna come into play. So now to prove this theorem, first let's read our statement. It's saying in the diagram below, center or O is a center. So first, by writing my given, I'm given that O is what is the center. So that is the first thing that you need to write down. O, it's a given, and then in the diagram to prove the following, or to prove the theorem which state that if OM perpendicular to AP. So another thing that is being given, I'm being given that OM is perpendicular to AP. There is two things that I'm being given. This is one of my givens. And then that's AM is equals to MB. So this is one is what? This is my required to prove. This is required to prove. This is the thing that I must be proving. So proving that AM is equals to MB. So from now, I needed to prove. In order for me to prove, there is a thing that I need to do. I need to construct somewhere, somehow. Now let's do my construction. Construction, I'll be joining these two parts, joining this AO and also joining these two parts, which is OB. Now joining from a line to a center to a circumference, another line to a center to a circumference, that's what we call it, what? A radius. See, these two lines are what? A radius. So my construction we join AO and what? OB. Then after joining those two things, now I hope you can see that we are having two triangles now. I hope you can see we're having this triangle here, which I'm going to highlight it as pink, and we're going to have another triangle here, which is this triangle here, which I'm highlighting with a green. Now congruency needs to come into play. If you still remember congruency from grade 11, from grade 10, sorry, that thing here is to come into play. Now let's prove now. Let's prove now. Now let's prove. Since we're having these two triangles, so in triangle AOM and triangle OMB. Now first thing, number one, we know that OM is equals to OB. Why are we saying that? A line that comes from the center to a circumference, there is a radius. So we are having these two radiuses, we call them radial. And then number two, we're being told, or it's given that this line here, or this OM, it's perpendicular to what? To AB. So we can say that an angle OMA is equals to an angle OMB. Why? It's that it's given. That is what it's given. We're being told about that. And then after that, number three, we can write now. Since we're seeing this triangle here, the pink triangle, and also this green triangle, both of these triangles, they have this side here that this side is also on a pink, is also on a green. So more or less they share this side. So OM is what? It's common. So OM is common. Now remember, to prove congruency, you just need three things. Now we can conclude and say triangle AOM congruent to what? To a triangle OMB. Reason being, right perpendicular hypotenuse side, and a common side, which is a side. This is the reason that I have when I'm proving this congruency. Now, therefore, AM is what? Is going to be equals to MB. Why are we saying that, or why I'm saying that? Because I've proven my congruency, because a triangle AOM is congruent to a triangle OMP. So that is theorem number one. It's very, very easy. You just need to know how to prove the congruency. So yeah, there it is. Thank you so much, guys, if you did watch this video, and if you thought this video was really, really productive to you, you can share the video, like the video. Don't forget to subscribe. Thank you so much, guys. Omake.